You ever get tricked by those riddles? The ones that sound super complicated, but then it's like, oh, it's just simple math. Like when they're like, you're driving a bus, 5 people get on, 3 get off, and you're trying to keep track.
Yeah, yeah.
It seems easy at first, but
But
it's like all those changing numbers kind of throw you off.
it's a clever way to make you think about tracking changing values, right?
Yeah.
And that's something we do all the time in programming. In fact, it's one of the core concepts that we're looking at today with this programming textbook, Two Variables and Assignments in DesiBooks.pdf.
Okay, so let's break this down. How does keeping track of how many people are on a bus, how does that actually translate to writing code?
Well, imagine instead of people on a bus, you have information flowing through your program. Variables are like these labeled containers that hold that information. It could be numbers, it could be words, anything, really.
So it's like a virtual storage box for our data.
Exactly. And we give each box a meaningful name
Right.
so we can easily access and change what's inside.
Yeah.
So instead of just some random box, it's like we label it number of passengers or ticket price.
That makes sense. But how's that different from just using equations like we did back in like algebra class?
Ah, that's a great question. And that's where the equals sign, that symbol, gets a little tricky because in algebra, that equal sign means both sides are like truly equal.
Right.
But in programming, we're talking about assigning a value to a variable. And the textbook actually does a great job of highlighting that distinction.
So it's less about stating a fact and more about kind of like giving the computer instructions.
Precisely. And a good example of that is this animated example they have in the textbook,
Okay.
where they show these series of assignments.
Yeah.
So you have x equals 5, and then y, x, then z equals x2, and finally x equals 3. And what's really interesting here is how the value of a variable can actually change as the program runs,
Okay.
and how each step influences the next.
Okay, I'm intrigued. Walk me through this example, like step by step.
Absolutely. So let's start with that first statement, x equals 5. What we're doing is assigning the value of 5 to the variable we've named x. It's like taking 5 marbles and dropping them in a box labeled x.
Okay.
Then we have y, x. Now, instead of giving y a brand new value, we're saying, hey, make y hold whatever's in x right now. So y also becomes 5.
Okay, so far so good.
That's right. Right.
Then it gets more interesting with z equals x2.
Because this is where that idea of assignment, not equality,
Yeah.
becomes super important.
Yeah.
We're telling the computer, okay, take whatever's in x at this moment, which
Yeah.
is still 5, add 2 to it, and then store that result, which is 7 in z.
So even though x was involved in that calculation, its own value doesn't change because we're not assigning anything new to x.
Exactly.
Gotcha.
And that brings us to the last step in this example, which is x where's 3. Now we're updating x to hold the value 3.
Mm-hmm.
But, and here's a key point, changing x now does not retroactively affect y or z. They keep those values that we previously assigned.
Whoa, so it's almost like each one of these variables, even though they can be used in calculations with each other, they're kind of like their own independent entities.
You got it.
This is blowing my mind a little bit.
Each variable is its own entity, and we control how its value changes using those assignment statements.
This is making me realize how important those assignment statements really are. It's like giving the computer precise instructions on what to put in those storage boxes.
That's a great way to put it. And those instructions can get even more interesting because the value you're assigning doesn't have to be a simple number.
Oh, right. The textbook talked about that. What were some of the other things we can assign to variables?
The possibilities are pretty broad. You can assign the value of another variable or even the result of a calculation. The mice example from the book illustrates this perfectly.
Refresh my memory about that example.
They start with 2 variables, litter size set to 3 and yearly litter set to 5. Then they use the assignment statement, annual mice, litter size, yearly litters.
So we're basically telling the computer to multiply the values stored in those 2 variables and then stash the result in a new variable called annual mice.
Exactly. The computer does the math, 3 times 5 gets 15, and stores the result in the annual mice variable.
This is making me think about how much easier this makes things for programmers. Instead of having to redo all the calculations manually if something changes, they can just update a single variable and the program takes care of the rest. That's incredibly efficient.
This simple calculation demonstrates the power of variables. Imagine having to change the litter size in dozens of places in your code if you didn't use variables. They're essential for writing efficient and manageable programs.
That makes a ton of sense. It's like that weekly wage example we talked about earlier. Use variables for your hourly rate, hours worked, and boom, you have a program that can calculate your pay no matter how many hours you work.
You've got it. But here's something to think about. Not all data is created equal, even if we're just talking about numbers.
What do you mean?
Think about the types of numbers we use in everyday life. Sometimes we need whole numbers, like when we're counting people on that bus.
Yeah.
But other times we need more precision decimals.
Yeah, like when you're baking a cake and need to measure out 1.5 cups of flour.
Exactly. In programming, those whole numbers are called integers, and those numbers with decimals are called floating point numbers, or floats for short. Choosing the right type of variable for the kind of data you're working with is super important.
So it's about more than just giving the variable a name and assigning it a value. We also have to tell the computer what kind of value it's dealing with.
You got it. And the textbook highlights how using the wrong data type can have some unintended consequences.
Oh, right. The test score example. What was it about getting a B instead of an A?
Imagine you aced your midterm and final exams 89 and 91, respectively. Clearly, an A, right?
Definitely.
But if your professor wrote a program to calculate the average using integers instead of floats, it would add 89 and 91, which is 180, then divide by 2. But since it's only using whole numbers, it would just chop off the decimal and give you a 90 instead of the 90.5 you deserve.
Ouch. That's a prime example of why understanding data types is crucial. You could go from celebrating an A to panicking about a B, all because of a tiny decimal point.
And it's not just about grades. Think about programming something like a medical device that calculates dosages.
Or the self-driving car we were talking about before. Even being off by a tiny fraction could have huge consequences.
Precisely. And that's why programming languages offer ways to convert between data types when needed. It's called typecasting.
So it's like putting on a different pair of glasses to look at the same data in a new way. If you realize you need decimals, after all, you can use typecasting to tell the computer to treat that integer like a float.
A perfect analogy. It's like giving the computer a heads up that it needs to be a bit more precise with its calculations. The textbook even gives a handy tip for converting an integer to a float, just multiply it by 1.0.
That's pretty neat. So we've got these tools to store data, manipulate it, and even change how the computer interprets it. It's like having a whole workshop full of options for working with information. But it also makes you wonder, are there limits to what we can express using these tools? It's kind of mind-blowing when you think about it, right? Like we're representing these real-world concepts, temperatures, dosages, whatever, as ones and zeros inside a computer. But are there things that we just can't express accurately?
That's a really insightful question because it gets to the heart of what programming really is. It's a way of representing the world in a way that computers can understand. And the textbook even touches on this idea with the concept of constants, like the value of pi. So these are like these unchanging values that we use all the time. But what about something more abstract? Like how do you represent time?
Right, because we can quantify it, sure, seconds, minutes, hours, but it's more than just numbers, right? It's like this flow, this constant moving forward.
Exactly. And it makes you think about the limitations of trying to represent something that's continuous and always changing within the confines of a computer program that ultimately has to break everything down into these discrete units.
So even with all these tools that we've been talking about, variables, data types, typecasting, there are still these boundaries to what we can truly capture in code.
Yeah.
That's a pretty profound thought.
It is. And I think it highlights the importance of not just understanding the how of programming, all the technical details, but also the why. Like every line of code you write, every variable you define, every data type you choose, it's all a decision point.
It's like we're creating this mini universe inside the computer.
Yep.
And the way that we choose to represent things in that universe has a real impact on how it behaves.
That's a great way to think about it. And that sense of agency, that ability to kind of shape these digital worlds, it's part of what makes programming so fascinating, I think.
Absolutely. This deep dive has honestly given me so much to think about, not just like the technical details of variables and assignments, but also this like bigger picture of how we use code to interact with and understand the world around us.
And that's what I love about these concepts, right? They're fundamental, they're the building blocks,
Right.
But they really do open up this entire universe of possibilities.
So, to anyone listening who's just starting their programming journey, remember, every expert coder you know started with these same exact fundamental concepts. So don't be afraid to experiment, don't be afraid to ask questions, and keep exploring. You know, who knows what amazing things you might create.
Well said. The important thing is to stay curious, right? Keep learning, keep coding, and keep pushing the boundaries of what's possible.
And that brings us to the end of our deep dive into the world of variables and assignments. We hope you've enjoyed this exploration as much as we have.